Right, grade 12, here's something new that's in the syllabus. Let's just quickly look at some products quickly. If I said to you take x plus 3 and multiply it with x squared minus 3x plus 9, I want you to notice a pattern. So just let's multiply this out. Okay, what is x times x squared? That equals x cubed. Okay, then do x with negative 3x is negative 3x squared, and then x with 9 is positive 9x. Okay, now look at this. If you do this, it gives you negative 3x squared, or positive 3x squared, should I say. That gives you negative 9x, and 9 threes are 27. Now, if you notice, these middle terms cancel, and you're left with x cubed plus 27. Now, would you agree that x cubed plus 27 then can be factorized as x plus 3 x squared minus 3x plus 9? Okay, now what is interesting here is I want you to look, so these are pretty much the same, but notice if you factorize, this is a sum of two cubes. The cube root of x cubed is x, the cube root of 27 is 3, so you can obtain this first linear factor by simply getting the cube roots of those two. Now watch the pattern now. To get the first term here, well, that's easy. What is x times what gives you x cubed is x squared, and what times, if you look at the last term, what times what times 3 gives you 27? It's positive 9. But it's actually the same as saying squaring that first term and squaring the 3. Now the middle term is easy because you'll notice that the signs are different. It's a plus and a minus, it changes, and you simply merely multiply the 3 and the x. Okay, let's see if it works if we go minus, and then we're going to summarize this. If you have a look at this, I said to you x minus 3, and I said to you multiply this thing out. Well, have a look at this. That's a minus, that's a plus, that's x squared and 9, you've squared, and then these two are multiplied here, x and 3 to give you 3x. But let's check if it works. Okay, x cubed plus 3x squared, great, plus 9x. Okay, what about these terms? Look at this, negative 3x squared minus 9x and minus 27. So those middle terms go missing, and we're left with x cubed minus 27. When you factorize that, if you look at this, if I said to you, so we know that if you take that, what's x cubed minus 27? If you have to factorize that, what would it give you? Well, x minus 3, cube root, square the x, change the sign, multiply the two middle terms, and square the last term. It gives you exactly that. So what are we trying to say when you factorize these kinds of cubic expressions? We're saying if you've got a sum of two cubes, or maybe a difference of two cubes, what we can do is we're not going to use the smiley face method here. All we do is another technique. We get the cube roots in the first brackets. Okay, there we go. And for the second bracket, we're going to firstly say, well, a times a squared is a cubed, or if you square, change that sign to a minus and multiply the a and the b, and the last term is always the second term here, all squared. B squared times b is b cubed, and likewise here, so it's a squared, that sign changes to a plus, ab, and then square the b. Okay, so if you had something like this, if we had to factorize it, these are the rules. If I said to you factorize x cubed plus 8, it's not a common factor, there's no common factor, there's no smiley face, there's no grouping. This is a sum of two cubes. What you do is you cube root the x cubed and the 8, giving you x plus 2. Then you square the x, change that middle sign to a minus, multiply the x and the 2, and square the 2, and you get it. If you multiply this out, it's pretty cool. Okay, what about x cubed minus 8? No common factor, no grouping, no inspection, smiley face method. The difference of two cubes. So we cube root, keep the sign, but get the cube root of x cubed, which is x, cube root of 8, which is 2. Then how do we do it? We square the x, to give me the x cubed, change that sign to a plus and multiply the two terms, x and 2, and then square the last term. And look at that. You've got it. Very, very cool. Okay, should we try another one quickly? What about this if you had, say, 64x cubed plus 125. No common factor. There's no highest common factor here. There's not an inspection method or grouping. So it's a sum of two cubes. The cube root of 64 is going to be 4. The cube root of 125 is 5. Great. Okay. Now what's 4x all squared is 16x squared. Okay. And then we change the sign, multiply those two, giving me 20x. And then what do we know? We then square the last term, giving us 25 there. And there you've got it. You've got your little factors there. What about 64x cubed minus 125? Cube root those, 4x minus 5. Keep the sign there, the cube root. Then square the 4x. 16x squared, change the sign to give you positive 20x if you multiply, and then square the last term. There we go. Now look at that. 4x times 16x squared is 64x cubed, minus 5 times 25, 125 negative there. And then if you multiply out, the middle terms vanish. So there it is, the sum and difference of two cubes. Okay, now what I want to do is explore an example where you solve for x in these kinds of equations. So have a look at this. If I said to you solve for x and I said to you 8x cubed plus 27 is 0, solve for x. Well, no common factor, no grouping, no inspection. There's two cubes here. So let's factorize this. Well, the cube root of 8 is 2. The cube root of x cubed is x plus 27's cube root is 3. Okay, square this and you get 4x squared. Okay, check it. 4x squared times 2x is 8x cubed. Great. Then you change the sign from a plus to minus, multiply the 2x and the 3, giving you that, and you square the 3 and you get 9 equals 0. Now let's solve for x here. Well, this doesn't look like it's going to factorize nicely. I'm going to use the formula. So this gives you 2x plus 3 is equal to 0. So 2x is equal to negative 3, and x is minus 3 over 2. Great with that one, that's no problem. What about this one? Okay, x is equal to, okay, it's, now, this is tricky, it's minus b, okay, plus minus the square root of b squared, which is b squared, minus 4a is 4. I'm just going to move that right across there. 4a and c. All over, let's bring it right into view there, all over 2a. Okay, I'm just going to tidy this up a bit here. That's 6 plus minus the square root all over 8. Now, what is 36? Let's just see, it's 36 minus, 9 times 4 is 30, what's that? 4 4 is 16 times 9, so the whole mess comes to, look at this, it's going to come to, what's that there? Minus 108. Ouch. A negative number there. So it's 36, and then we've got this, I think, what's this? 9 times 16 is 144. Okay, there we go. Sorry. That gives us to this number here. Okay, so it's 36 minus the product of 4, 4, and 9 gives you 144, and then if you work that out, you get minus 108, and that's negative. So this is non-real. So you can't use that. So your only real solution is going to be minus 3 over 2. Now, what is interesting about the quadratic factor in these kinds of equations is that the quadratic factor always has a non-real solution. So you go minus b plus minus the square root of minus 6 squared, minus 4a is 4, c is 9, and then you work it out, you get to negative 108. That's non-real, and the quadratic factor never factors into rational factors. Okay, but what you could do, a shortcut to get the answer could be something like this. If you've got this, what you can do, if you like, is simply do a little shortcut. Bring that across, and then simply divide both sides by 8, and then cube root both sides. So the cube root of x cubed is x, and then if you cube root this, what do we get here? Look at that. The cube root of minus 27 is negative 3. The cube root of 8 is 2. And it gives you the answer direct. So remember that. It's quite simple. Okay, another one, for example, let's have a look at the 64x cubed minus 1. The one way you could approach it is to say, well, there's no common factor. It's not a smiley face. There's no grouping. So what we could do is we could say, well, let's factorize it like this. The cube root of 64 is 4. X cubed becomes x. The cube root of 1 is 1. Then square the 4x. Change the sign and multiply the two middle terms here. And square, and that equals 0. So you've got 4x minus 1 is 0. So 4x is 1, and x is a quarter. And this one has a non-real solution. You don't even have to try it. If you want to test it, you're welcome to do that, but it's going to have a non-real solution. And if you don't believe me, watch this. If I just go down here, I'm going to show you quickly. We've got 16x squared plus 4x plus 1. Let's see if it does work this way. X is minus b plus minus the square root of b squared minus 4a and c. If you plug in those values all over 2a, and that will come to, watch this, it's clearly obvious here, negative 4 plus minus the square root over 32, that's going to give you negative 48 if you work this out. 16 minus 6, well, there it is, non-real. You can see it's not going to work. Okay, so with these kinds of equations, what we do, so if you've got 64x cubed minus 1, you say, look, it's a difference of two cubes, no common factors, smiley face won't work, grouping won't work. All you then do is you say, well, 64x cubed is 1, x cubed is 1 over 64, and what was the original answer there? Look, a quarter here. Great. So we then go and say, fine, x is the cube root of that, which is a quarter, which is your answer. So remember that with these kinds of equations, you're not going to have a real solution with the quadratic factor.